Hello everyone, good evening. I hope all of you are good and I am also good. So today I will take another class from physics, that is class 11, from motion 1D, that is motion in a straight line, and from that topic we will do some questions which came in NEET and IIT JEE. Okay, and the topics will be differential or calculus related. Okay, differentiation and integration related or calculus related numericals we will do from the chapter motion in a straight line. Okay, so many questions came in the previous year exams, that is JEE mains and IIT. Okay, which is related to calculus. So now we will do some questions from the topic calculus related topic. Our first question is like that. Okay, a car moves along a straight line and whose equation is given by s is equal to 12t plus 3t square minus 2t cube, s is in meter and t is in seconds. The velocity of the car at the start will be, that is at the start, that is the initial velocity of the car is what we have to find out. Okay, at the start means at t equal to 0. So what is given here, that is s is equal to 12t plus 3t square minus 2t cube. So ds by dt equal to 12 d by dt t plus 3 d by dt t square minus 2 into d by dt t cube. So 12 into 1 plus 3 into 2t minus 2 into, this one is 2 into 3t square. Okay, so it will be 6 12 plus 6t minus 6t square. So at the start, this one is what, sir? This one is velocity, this one is the velocity. So at the start means at time t equal to 0. So at the start means time t equal to 0. So velocity will be what? V equal to 12 plus 0 plus minus 0. Okay, minus 0. So B will be 12 meter per second square. Okay, so B will be 12 meter per second square. So which option is correct, sir? 12 meter per second. Option C is the correct answer. Option C is the correct answer. So let me explain again. A car is moving along a straight line whose equation of motion is given in as function of t, and the velocity of the car at the start will be able to find out. So velocity from distance we can find as if I differentiate the distance. Okay, so ds by dt will be this one, and at the start means at time t equal to 0. So you put the time t equal to 0 here, you will get 12 meter per second is the answer. That is velocity of B. Okay, so now we will move on the next question. So our next question, the next question is motion of a particle is given s is equal to 3t cube plus 7t square plus 14t plus 8 meter. The acceleration of the particle at the time t equal to 1 second. So acceleration will be find out. Okay, 4 option is given here. So here given s is equal to 3t cube plus 7t square plus 14t plus 8. So if you differentiate this, it will be dx by dt equal to 3 d by dt t cube 7 d by dt t square plus 14 d by dt, okay, plus d by dt into 8. So if you differentiate it, it will be 2 3 t square 7 into 2t plus 14 into 1 plus 0. So 9t square plus 14t plus 14. Okay, so this one is scheme, this one is velocity. Now if you differentiate again, it will become 9 into d by dt square, 9 into d by t square plus 14 into d by dt to t plus d by dt 14. Come at here. So d by dt is acceleration. So 9 into 2t plus 14 into 1 plus 0. So A is 18t plus 14. Now you have to put the value of t is what? T is, sir, given t is here 1 second. So if we put 1 here, 18 into 1 plus 14, that is 32. 32 is the answer. 32, option B. Oh, this one is 32. Option B is the correct answer. So 32 meter per second square. acceleration is 32 meter per second square. This one is 10 meter per second square. 3 meter per second square, 9 meter per second square, 15 meter per second square. Okay. So what is given? A motion of a particle is given by equation s is equal to 3t cube plus 7t square plus 14t plus it. Okay, right? The acceleration of the particle at time t is what we have to find out. So distance is given. So from distance we can, if a derivative, the distance with respect to, if we do derivative, differentiate the distance, we get velocity, right? And after that, if I do differentiate with respect to time, the velocity, then we will get the acceleration. So acceleration is came out 18t plus 14. Okay, here you know this formula, ddx of x to the power n, formula is n into x to the power n minus 1, and ddx of x is what? ddx of x is 1, and ddx of constant is 0. Everyone know this formula, is not it? So here x n is 3, that is 3 into 3 to the power 2 minus 1, that means 3 into t square. Here will be 2 into 2 minus 1, that is 1, and 14 into t 1, and constant is 0. Okay, I use this formula also, only 3 formulas, that is ddx of x to the power n, all of you know this, n into x to the power n minus 1, and ddx of x is 1, and ddx of constant is 0. Okay, so move on the next question. So students, our next question, this is our third question. The displacement x of a particle varies with time as x equal to a e to the power minus alpha t plus b e to the power beta t, where a, b, c, alpha beta, a, b and alpha beta are positive constant. The velocity of the particle will be what? We have to find out. So 4 option is given, which option is correct? We have to find out. Okay, so let's try to write the equation. This x is equal to a e to the power minus alpha t plus b e to the power beta t. If I do differentiate here, it will be become dx by dt will be a d by dt e to the power minus alpha t plus b d by dt e to the power beta t minus e to the power alpha t plus b beta e to the power beta t. So minus a alpha e to the power minus alpha t, b beta e to the power beta t. This one is velocity. Okay, this one is velocity. Now look at the options. It is independent of beta, never. Here is beta is given, so the value of beta will be, that is velocity of b will be dependent, that velocity b will be dependent on beta. Here beta is given in the expression, is not it? So this option will not correct. And b drop to 0 when alpha and beta. No, if alpha and beta are equal, it is not drop to 0, because it will be 0. Here a and b are positive constant, so if alpha and beta are equal, then here will be a alpha, here will be b alpha, but it will not be 0. Okay, this option is not correct. So go on decreasing with time, since alpha, so go on decreasing with time. So for that we have to find out the acceleration. So dv by dt is what? Minus, this will be a alpha minus alpha e to the power minus alpha t, and b beta into beta e to the power beta t. Okay, so it will be a alpha square e to the power minus alpha t, b beta square e to the power beta t. Okay, look at this one is acceleration, no? So velocity will go on decreasing with time, that is it is go decreasing with time, never, because this one is positive, this one is positive, and all the constant alpha beta and a b are constant, so it is going increasing. So this option is also not correct. Go on increasing, yes, go on increasing with time, because look at here this one is positive, this one is positive term, and alpha and beta are positive terms, and e to the power something is never be negative. Okay, so here alpha square and beta square is there, so all are positive terms, so it is option D will be the correct option, that is go on increasing with time. This is the correct answer. Okay, so let's move on the next question. So our next question, that is question number 4. Given that a equal to 2t plus 5, so calculate the velocity of the body after 5 seconds if it starts from rest. Okay, 4 option is given, which option is correct? We have to find out. So here acceleration 2t is 5. So acceleration we can write dv by dt. Here we have to do integration, because when you have to find velocity from acceleration, you have to do reverse case, that is integration. So dB equal to 2t plus 5 into dt. So take integration here, 2t plus 5 dt plus c. B here it will be t into 2 square by 2 plus 5 into t, okay, plus c. Now putting what? The velocity of the body after 5 seconds if it starts from rest. So if it starts from rest, it will be 0 and b will be 0 first. So b will be what? T square plus 5t. So c will be 0. 0 equal to 0 plus c. So c will be 0. You can write in this way, or you can use integration limit also. So b will be t square plus 5t. Now putting here t equal to 5. At the start this one is 0. After 5 seconds, if you start from 0, so that is at the start this, it will be b equal to 5 square plus 5 into 5, that is 50 meter per second. Okay, here this part you can do with integration also. There is 0 to b db and integration 0 to 5 2t plus 5 dt. If you use different integral here, you can do in this way also. This is another method. Okay, here will be b and it will be 2t square by 2 plus 5t 0 to 5, then b equal to t to cancel, the 5 square plus 5 into 5. Okay, so b will be 50 meter per second. So you use in two cases. First I take in integration plus c he has given, and b is come this one, we have to find out c. If we put b t equal to 0, it will be b equal to 0 at the start. So c equal to 0. If we put c is here, so b will be what? 2t square, t square plus 5t. And now put the value of t is 5 and you will get 50. And here you can use direct its lower limit and upper limit. That is 0 to 5, 2t plus 5 dt. So after integration this one came and you put upper limit and minus lower limit, and its answer will become same. Okay, so which option is correct, sir? Option A is the correct answer. So option A is the correct answer. Now we move on the next question. So our next question, that is question number 5. A particle located at x equal to 0 at time t equal to 0 start moving along a positive axis with a velocity v that varies b equal to a root over x. The displacement of the particle is varies with s. So b equal to a root over x. Okay, the displacement we have to find out. So we can write dx by dt equal to a root over x. So dx is equal to a root over x dt. So dx by root over x equal to a dt. So dt. Okay, x is positive velocity, the speed of the particle varies with time s. So you differentiate this one, it will be x to the power minus half and dx a into dt. So it will be x to the power minus half plus 1 minus half plus 1 equal to a dt. So it will be x to the power plus half by a into t. So 2 root over x is equal to a into t. So root over x is equal to a by 2 t. So x square equal to a square by 4 t square. Now x equal to x square by root t square. So this one is constant. So x varies with t square time. So which option is correct? Option C is the correct answer. So a particle located at x equal to 0 at time t equal to 0 starts moving along a positive axis with velocity b and varies as b is given, that is b equal to a root over x. The displacement of the particle varies with time is what? So b equal to a root over x, I convert b dx by dt. I after that time multiplied and taking integration. After that simplifying, what comes? This one is came. So a root over x equal to a by 2 t square. So x is what? If I do square both sides, it will be x equal to s square by 4 into t square. So x very proportional to t square. So option C is the correct answer. Okay, option C is the correct answer. So we will move on the next question, that is the last question. Okay, so our next and last question, that is question number 6. an object moving with speed of 6.25 meter per second decelerate at a rate of given dy dt minus 2.5 root over b, where b is the resistance speed, the time taken by the object to come to rest. That is, suppose one object is moving in deceleration, that is the speed is decreasing with time. Okay, its speed is decreasing with time. So at a certain time it comes to rest. Okay, so when it comes to rest, that time we have to find out. So let's see what is given. Db by dt equal to minus 2.5 root over b. So db by root over b equal to minus 2.5 into dt. So if I take integration here, it will be 0 to 6.25. okay, so its starting velocity is 6.25 and final velocity will be 0, and db by root over b, and minus 2.5 into dt, it will be 0 to t. So 6.250, it will be minus half db minus 2.5, it will be t minus to t 0 to t. So 6.250 to t, that is it will be b to the power half minus a plus 1, that is b to the power half by half. Okay, no, I have to do integration here. If I do integration, it will be my to the power plus half minus half plus 1 and minus half plus 1. So 6.25 to 0, here it will be minus 2.5 t minus 0. okay, so b to the power half by half 6.250 into t, so it will be 2 root b, that is 0 and 6.25, it will be minus 2.5 into t. So 0 minus 2 root over 6.25, it will be minus 2.5 into t. So minus 2.5 equal to minus 2.5 into t. So this will be cancelled. So t equal to 2 seconds. So 2 seconds is the correct answer. So correct answer will be 2 seconds. So which option is given? Option 2 is the correct answer. Option B. Okay, option B is the correct answer. So let me explain again in short. Here given this equation, I simplify. First I simplify it in differential form. After I take integration, that is initial velocity is 6.25 and initial time will be 0. Final velocity it will be 0 and time will be t. We have to find out. So after doing simple integration, after that this one is came. If I put upper limit minus lower limit here, it will be something like that. 6.25 equal to 2.5. The root over of 6.25 is 2.5. So minus 2.5 minus 2.5 will cancel. So t equal to 2 seconds. So t equal to 2 seconds is the correct answer. Okay. So let's do another questions. Okay, do it. So this much for this class. This I will come shortly in next day. Will be upload another video from these topics, that is from relative velocity and average velocity. Okay, so relative velocity and average velocity content I will do make another video and it will come on tomorrow evening. Okay, so thank you for watching. Have a nice day.